So, of course, this is trigonometry. Why did I start my warm-up thing with trigonometry, even though it is the very last thing we're going to do this year? I lie, second last thing we're going to do this year. Nick, why did I start with trigonometry? This is a test, Nick. You were in my class last year. Why did I start with trigonometry? Anisha, why did I start with trigonometry? No. Yeah, because it's the best. The kid from Chile. I would have had it. That's okay. The kid from Chile knew. At the end of the year, I'm going to give you all what's that stupid game you play with your phone? And it starts with a K or something. Kahoot. I'm going to give you all a Kahoot of all the things I've told you all year. I'm going to see who passes the Kahoot. And it's not going to have anything to do with math. I'm going to see who's been paying attention to stuff I say. What? Nothing, because it's not got anything to do with math. I only care about how you do math for whether you pass. But I will have hurt feelings if you don't do well on it. All right, let's do math. Again, trig, my favorite thing, so I started with trig. But Anisha, you were technically right, because it was the last thing we did last year as well. So I feel bad now. In all that time I was talking, I was thinking, wait a minute, Anisha was right, and I need to give Anisha credit for getting it right. So here it is. Well done. Nick? Boo! Hurtful. All right. I hear Derek is a peer tutor in another class. I hear he's doing well. Did you do peer tutoring? Oh, did you do peer tutoring? Yeah, you. Nobody else was in my class last year, so I don't care. Oh, Jaden, did you do peer tutoring? You have next semester. What are you tutoring? Do you know? No. Next semester, I have all pre-calc 11. Why would you tutor the class you just took? Well, that's not true. I have a grade 10. I do have a grade 10. If you need to tutor in block next semester, you can come and see me. I don't remember what block it is because it's next semester, and I don't believe in borrowing problems from the future. I recorded all of that. So, just to be fun, I drew the triangle backwards from the way it's drawn in the diagram. Does that matter? Of course not. Could I have drawn it upside down? No, I wouldn't have drawn a penis. You can't do trigonometry with a penis. There's no 90 degrees in it. So you probably should, if your penis has a 90-degree bend in it, you should probably see somebody about that. Okay? Like, I'd be really, really worried if I were you. And it would be really tough to meet the girl for the first time, right? Or I shouldn't say girl. It would be really hard to meet your partner for the first time. You'd be like, can you roll over 90 degrees so this works? So, this is where you learn how to read the room. I was making a little joke, right? Because you said penis, and I've said it 1,000 times to see if you're still 5-year-olds and can't say the word without being clowns. This is where we realize that this is still a place of business, and we can't have fun if you have to act like penises. Clear? All right. So, would it have mattered if I drew this upside down? Would it have mattered if I drew it on an angle? Would it have mattered if I drew it backwards? Would it have mattered if I drew it in green? Of course not, because the math is always the same. That's 72, that's 12, this is the answer you need. So of course, you use tangent of 72, which equaled x over 12, and then of course you remembered grade 8 algebra. When the variable is in the numerator spot, you would have multiplied both sides by 12, canceled the 12s, and gotten 12 tan 72 equals x. And the answer is... Sure. I have no idea. I don't have my calculator, and I'm believing you. I got a 36.9. I got a 37.9. I don't care. I'm writing 37. I don't care. And there's a reason I'm doing this. This is what is important to me. If you show me the right work, but you have potato fingers like me and you hit the wrong button on your calculator, Will I do that grade 3 math teacher thing where they say the entire question is wrong and give you 0? No, of course not. But what if you don't show me any work and get the wrong answer? Then what will I give you? Nothing. Does everybody understand? Okay? And the actual answer, now that I'm worried about it, is 12, 10, 72, 36.9. So 37 would be fine. I like one decimal place, so really 36.9 is the best answer. Okay? Everybody cool? All right. Now, how does this affect you? What am I going to do with this information? You are going to go through this by yourselves. If you got all of this, you're going to give yourself just 1 mark. It's not for marks. It just means you got it. If you didn't get all of this, then you give yourself a half. Is that clear? You're going to report to me your score, and I'm going to show you this again later. You're going to give me a comment for what questions gave you the most, if any, problem. Are we all clear? Excellent. Let us carry on then. Cabbages. I'm sorry, Anisha and Nick. You will hear the same joke numerous times because this is your second time through with me, and you, Jaden. Everybody else, all my jokes are original. You'll love them because I write new material every summer. I don't. Let's go. Next one, same thing. Doesn't matter how you draw it. Could you draw it with a 74 there? Of course you could. There, where would you put the 6? Horizontal or vertical? Where is the 6 if you put the 74 there? It is horizontal. That is 6, and there's the hypotenuse. What if you put the 74 up here? Where is the 6? Vertical. Still the hypotenuse there. Doesn't matter. Of course, since you have an adjacent and a hypotenuse, you are using cosine of 74 equals 6 over x. Then, of course, you are remembering grade 8 algebra, and x equals 6 divided by cosine 74. And I have no idea what the answer is, so you can tell me while I punch it in. 21.7? Sounds like it's probably right. And it is, well, it's 21.8 because we are in grade 11 pre-calculus and we all know how to round. Don't make me do a lesson on rounding. That hurts me at the bottom of my soul to have to teach grade 11s how to round. But I will if I need to. Solve the triangle. Now, I believe that this triangle is bad. I think that when I was making this up and I was just putting random numbers in, I made a triangle that doesn't work. I think. But let's check. To solve a triangle, you need to find all the parts of it. So you need this angle right here. How big is angle C? 60 degrees, because the angles in a triangle add up to 180. And then you needed to find this side and this side, yes? Now, lots of ways you could have done it. Again, the chances that you did this exactly the way I did it are probably going to be not very high, so wait until I get to the answer. If I was finding y, I would say tangent of 30 equals y over 20. And then 20 tan 30 would give me y, which is 10, I believe. Nope, 11.54. 11.5. Yeah? Yeah. And then you could use Pythagoras. You could do 20 plus 11.5, 20 squared plus 11.5 squared, and then square root. Or you could also do cosine of 30 equals 20 over x, adjacent over hypotenuse, and x would equal 20 divided by cosine 30, which would get you 20, 30, which would get you 23.1. Yeah? Again, don't really care what order you did it in, and you could have done it in other ways, but your answer should be close to those three numbers. If they're not, then you need, when you go to Google Classroom, you need to say, I don't really remember trigonometry. Everybody cool? It's 23.1. Yeah? All right. Okay, everybody, let's take a moment, dry our tears. Our review of trigonometry is over. We won't be doing trigonometry again until near the end of the semester. It's a long wait. It makes me sad. I know it makes you sad too, because trig is your favorite thing too, right? Are you serious, or are you just trying to score some points? Nice. Trig rocks, I know. Trig is good times. No? 100% no? Like you hate it? Like if trig came over to your house and was like, what's for dinner? You wouldn't even open the door? Wow. That's so, ooh, jeez. So if trig was the last thing you could take to the prom, you wouldn't even ask it? No promposal for trig? Sad. Okay. 4, 5, 6, 7. Factoring is something that a great many of you aren't great at. I don't mean you. I shouldn't have said that. A great many of your peers have a lot of trouble remembering how to factor. There's a lot of ways to do it, a lot of different methods. I can't show you all the methods, so I'm not gonna. But suffice to say, you remember how add, subtract, multiply, divide was the only math you needed to know to get up to and through most of grade 10? Okay. Factoring is the add, subtract, multiply, and divide of pre-calc 12 and calculus 12. That's how good you have to be at factoring to go further in math, right? If I say what's 22 plus 67, and you obviously know the answer is 89, you also need to be so good at factoring that you can do all of these like that. Does everybody understand? Okay. So I'm just going to write the right answer here because I personally know 5 methods for how to factor that. And obviously when we get to this new factoring in grade 11 and I review grade 10, I'll show you all 5 methods. And it'll be your choice to choose the one you like. One of them will be what your grade 10 teacher showed you, okay? Or if you're from another country, what your grade 4 teacher showed you, because in other countries they really do math. Nothing? Nothing? Okay. All right. The answer is, of course, 2x plus 1 and x plus 7. You could also have written x plus 7 and 2x plus 1. That would have been fine as well. Okay? You could not write 2x plus 7 and x plus 1. Everybody cool? And remember, if you forget how to factor those, don't worry, I'm going to remind you. But you will put in Google Classroom, I don't remember how to factor. Okay? Okay. For this one, since it has a greatest common factor, you would take out the greatest common factor, which is 9a squared c. And you would rewrite this as 9a squared c times 2a squared c squared minus 3c cubed plus a. And that would be your final answer. Yeah? Sweet. And the next one is... what color do I want? Pink. X minus 8 times x minus 8. Or, of course, the shortcut, because math people are lazy, that. Huh? Thanks. And, of course, the last one is I would take out a 4 first and get x squared minus 9. And then, of course, you would have 4x plus 3, x minus 3. And again, Even if you don't remember how to do it, you don't need to worry because you're going to see it again. Okay? Now, by a show of applause, how many people actually remember factoring? Okay, good. That makes me very happy. Okay, describe a possible scenario. What could be happening in the real world that this graph would show? Anybody? A roller coaster. Yes, it could work for a roller coaster because when it starts, you're at the beginning, and then you get further and further away from the beginning, and then at some point you're halfway through the roller coaster ride, and you start coming back. It's not the best example, but it will work. You got one? A hot air balloon. Yes! I would say it was height as opposed to distance, but still it works. As time goes on, the balloon goes up in the air, and then the balloon comes down. Thankfully, the balloon came down safely, because, of course, if it didn't, it would be more like this. Ah! But we don't want any hot air balloon accidents around here, do we? Just between you and me, I am scared of almost nothing. Hot air balloons scare the crap out of me. You couldn't pay me enough to ride in a hot air balloon. And you know all those movies where the guy takes the girl up in the hot air balloon and he asks her to marry him and everybody's like, oh my God, so romantic. If my current wife, who's a forward-thinking modern woman, wanted to propose to me and took me up in a hot air balloon, I'd be like, obviously you don't know me, I'm out of here. And I wouldn't have married her. That's not true, I totally would have. Totally would have. I was punching way above my weight when I married my wife. Anyways. Anybody else got another one? What's yours? Yep, a ball thrown in the air or thrown a distance, right? Doesn't matter. The whole point is you tell me something left its starting point and came back to its starting point. Everybody cool? Anything that has those three parts works. Of course, you could make it better by saying it left its starting point and came back at exactly the same rate. Something like that, but I don't really care. We'll get to that later. Everyone is good? Spectacular. Oh, this one caused a lot of trouble in the other class. So, what does your graph need to look like? Pardon me? Yes, it would be it's trapezoid. It's exactly a trapezoid, as a matter of fact. What would be down here to do a good graph? What are the two things I'm counting? Time and speed. So what goes here? Time, because time is the independent variable. What goes here? Speed. I speed up very quickly, yes? So I need a steep or a shallow line first. Steep. Then when I get to top speed, what do? I stay there for a while. Does my speed change? So how do I show my speed not changing but time moving on? Horizontal line. Excellent. And then what happens? I slow down. Do I slow down at the same rate or slower? So is the line the same, shallower, wait, I'm going to use three different colors, shallower, or three different colors, you idiot, steeper, blue, pink, or red? Blue. That's what your graph has to look like. Well, of course, you would keep it on the graph, right? As long as it's steep, flat, shallow, I'm happy. Everybody cool? Yeah. Put some points on the graph. Oh. This makes me sad when people have trouble with this one. -2, 7. -2, up 7. 1, 2, 3, 4, 5, 6, 7. -1, 5. 1, 1. 4. 1, 2, 3, 4, 5. There's your dots. Is it a linear relation? Yes or no? Yes, of course it is. It is linear. Why? There's no line there, Mr. Mars. No, there isn't a line there. There's just points. But how do you know it's linear? Because if you put a line there, it would be straight. Down 2 over 1, 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 and you hit all the points because it has a constant rate of change. Everybody good? Now, some of you probably wouldn't have used the words constant rate of change. You might have said the slope is the same. That would have been fine too. Everybody good? Sweet. Oh, number 11. Number 11 caused much grief again in the other class. What do I do with that negative 3? Don't all answer at once. It's hard to choose. Domini, right? You substitute it in wherever there's an x, because if you don't know what it is, it's still an x. But here you do know the x is negative 3. So the f of negative 3 equals negative 3 times negative 3 plus 7, which is 9 plus 7, which is 16. Now, which of those, yellow, blue, is an x value if I were to put it on a graph? Negative 3. And which is the y value? 16. So if I had a graph, negative 3, 16. That would be the point. Agreed? Okay. Now, I didn't put this question on here because it always causes much grief. What would you do with this? No, wait, that's a bad one. Let's go with, negative 2. How is that different? Because every kid screws this up no matter how often I try to teach it to them. Where does that negative 2 go? Where does that negative 2 go, Leo? In the, right there where the x is? No. It's okay. Everybody screws this up. How is this different? It's not in the brackets, right? That is f of x. That is f of x. So this is negative 2 equals negative 3x plus 7. And now what do you have to do? Now you have to find x. So of course you'll bring that 7 over there. Negative 9 equals negative 3x, and x equals positive 3. And on a graph, of course, it would be positive 3, negative 2. Everybody remembers that? We are going to use that a lot this year. You must know the difference between x and f of x. If you don't remember, which of course some of you don't, hopefully you do now, but if you don't worry, I'll remind you. Next thing, I want the x-intercept of each line given its slope and its y-intercept. Well, how do you figure this out? Well, there's a few ways. You could remember this move. What's the m? Slope. What's the b? The y-intercept. So it would be y equals negative 5x plus 20. And every x-intercept in the universe is x comma 0, yes? That's an x value, that's a y value. X, y. There's a y. What number do I put there? X comma 0. There's a y. There's a y. What number goes there? 0. 0 equals negative 5x plus 20. Negative 20 equals negative 5x. X equals 4. There's an x. X is 4. The x-intercept is 4 comma 0. Everybody remember that? Same thing here. 4, 0 again. negative 1.5. Just let me check that. Yes. And we should be good. Everybody okay? Find the equation of the line that passes through here. There are three ways to write this line just from how you look at it. The first thing, you always need to find the slope. So the slope is 5 minus 3 over 4 minus 2. Or I could do 3 minus 5 over 2 minus 4. But you would get the same answer. What is it? What's 5 minus 3? What's 4 minus 2? What's 2 over 2? 1. So the slope is 1. So you could have y minus 3 equals x minus 2. You could have y minus 5 equals x minus 4. You could have y equals x plus 1. Oops, different color. Y equals x plus 1. Any one of those three. Graph that system. I didn't give you very much space to graph that system. Negative 3, positive 3, boom. And positive 9, 9, boom. And the answer is where they cross. That's what I'm looking for. I don't care what the value is because I didn't give you enough space to graph it. Anisha. 12C. Yes, 3 over 2. Of course. And lastly, a system. A, adults plus children equals 400 tickets. $13 for adults plus $8 for children equals $4,650. Then you solve it. You could solve it by elimination, or you could solve it by substitution. Or you could graph it, but graphing sucks. So you would do substitution or elimination. Most likely, you said A equals 400 minus C, or C equals 400 minus A. Then, wherever you see the letter A, you would put this. So you would have 13 400 minus C plus 8C equals 4,650. 5,200 minus 13C plus 8C equals 4,650. Negative 5C equals negative 550. I think I'm doing this in my head. And C equals 110. If C is 110, adults are 290. 290 adults, 110 children. And then you'd be done. Are we all good? Okay. Now, again, when you get a chance, send me your score out of 15 and listen to me carefully. There's 3 levels for each of these questions. There's I remember how to do it, I got it, no problem. There's, I remember how to do it now that I've seen it. And there's, I'm in the wrong room. Everybody got it? You need to tell me what questions here are these 2. I remember how to do it now that I've seen it, and holy crap, I'm in the wrong room. And everybody will show me that on a private comment. Do not put it on the Google Classroom stream or everyone will see. Just to me when you report your score out of 15. Then I will, because I'm a super nerd, tabulate it all, make myself a little spreadsheet so I can make myself a little graph and I can see what topics I need to hit extra hard before we start the grade 11 part. Are we all good? Yep. Excellent. Take a short break, talk amongst yourselves, post on Discord about how great your math teacher is. We'll be right back together in a moment. Go. Okay. I would like to spend one part of a class discussing numbers, because of course this is a math class and we use numbers. Okay, we will begin. Cast your minds back to kindergarten. When you arrived at kindergarten, because you were intelligent young people, and the teacher said, let's count, class, all of you would have started with what number? That's the problem. See? You can't even agree where to start counting. How am I supposed to teach you math? You would all start with the number 1. Nobody would start counting with the number 0 unless they were super nerd parents who are like, actually, Mrs. Backcrumble, the first number is 0. You would all start with 1, right? And we'd all go 1, 2, 3. And how far could we count? Technically, how far can you count? Infinity. You can count forever, can't you? Right? But you only, we don't count that high. Here's a little piece of trivia for you. Guess what in kindergarten the goal at the end of 10 months of school for math is? Guess what the goal is? Jasleen? Lower. 10. 10 months of kindergarten to learn to count to 10. And we wonder why we're falling behind the rest of the world in math. So, 1, 2, 3, up to what? No. In reality, not kindergarten. Infinity. Now, I like the sideways infinity sign because you can turn it into eyes really quickly. You don't have to make your infinities eyes. Who is that supposed to look like? He doesn't have any glasses on. Now it's exact. There we go. All right, easy peasy, yes? Okay. Now, if this group of numbers goes to infinity, then there's an infinite amount of numbers there, yes? And infinity is a number that we can't possibly comprehend. It doesn't really exist. So we're good, yeah? Okay. So I'm going to draw over here. And earlier today, I made the analogy that numbers are like those Russian dolls, but I couldn't remember the proper name for them. And then somebody told me the proper name for them, and now I've already forgotten it again. But you all know those dolls I mean. The little doll and the next doll, up to the big doll. They're Petrushkas or Nitrishkas or Matrushkas. I can't remember. But the natural numbers are there, and there is an infinite amount of numbers there, correct? Okay. Whole numbers is the next group. Now, if I say whole numbers, you all think I mean this. The 3 in this, right? That's not what we mean when we're talking about numbers. We mean whole numbers are the naturals plus 0. So 0, 1, 2, 3, up to infinity. Are there still an infinite amount of numbers there? Yes, but it is technically one number bigger than the naturals because of the 0, yeah? Even though they're infinite in both, this is technically just slightly bigger, yeah? So why is it like the Russian dolls? If you're a natural number, you're already a whole number, okay? This is like the littlest Russian doll, way down in the middle. Next, integers. Integers are the naturals plus what? Manthan, you just said it. Negatives. Naturals plus negatives. And this is about where math started to go a little haywire for a lot of you. Like you were okay up till negative numbers, and then the next one. These two are the problems because negatives mess up your thinking because it's hard to count them, right? Like it makes sense. 1 finger, 2 finger, 3 finger, 4 finger. How do you show me negative 4 fingers? Damn, right? You can't see it. You can't visualize it. So negative infinity, negative 1, 0, 1, to positive infinity. Everybody cool? And that would go here, integers. We all good? Now you will notice what is not there at all. 1, 2, 3. 0, 1, 2, 3. Negative 1, 0, 1, 2, 3. What haven't I talked about? Fractions. And this is where math really went sideways for a great many people. Cast your minds back. Your mom tells you to clean your room. When you're little, what do? You clean your room because you're little, right? You listen to your parents back then. Then you're 8 or 9 and your mom tells you to clean your room, but you don't feel like cleaning your room. You want to watch, what's a show that you would have been watching when you were 8 or 9? SpongeBob, of course. SpongeBob, yes. You would have all been watching SpongeBob. I wish you were watching, even Dragon Ball Z would have been better. But, yeah, I know. You want to watch SpongeBob, so your mom says clean your room. What do you say? No, I want to watch SpongeBob. So what does your mom do? I don't know about your mom. She counts. And she goes, 1. And you're like, oh, damn, this is trouble. And then you go and clean your room. I know that's what my mom did too, Pavan. No, I don't want to clean my room. Bam! Yeah, you do. But, things are different now. And you said, okay, no problem, Mom. And then 2 weeks later, your mom says, clean your room. You say, no, I'm watching SpongeBob. And your mom goes, 1. And you're like, no, Mom. 2. And you're like, oh, I better go clean my room. Because you didn't want your mom to get to 3. Here's a hint. Your mom didn't know what they were going to do when they got to 3 either. So what did your mom do the next time you said no? 1, 2. What's the next one? 2.5. They don't want to get to 3 because they don't want to have to do any discipline. And you all of a sudden, you're 6 years old. What the hell is this half stuff? And that's where math screwed you all over. Because all of these numbers go to infinity, yes? How far is it from 0 to 1? Also infinity. Because you will never get to 1 if you keep cutting it in half. Does everybody understand? And that is where, for most of you, math goes in the pooper when we start splitting up numbers and making fractions. Because you're still scared of fractions. So, rational numbers. They have to look like that. X and Y have to be integers. And Y can't equal 0. Easy peasy. So let me ask you this. Don't write this down, just think. Is that a rational number? Why? Because it is. Is this the coolest math teacher in the world? Yes, because I am. But no, you need a reason. Why is that a rational number? Okay, that's true, but let me ask you this, Gavin. Pi is 3.14 blah, yes? But is pi a rational number? No. So change your definition slightly. Why is this rational? I'll give you a hint. It's already written on the screen. Jasleen? Because it's not a whole number, okay, but neither is pi. And it's irrational. I'll tell you again. I'll even highlight it. Why is that a rational number? Nope. It's highlighted, kids. Is that an integer? Yeah, it's right there, integers. Is that an integer? 1, 2, 3. Is 3 equal to 0. So is that a rational number? Yes, because it's two integers and the denominator isn't 0. So let me ask you this. Is that a rational number? 2.5 is an integer? No. But is 25 an integer? Is 35 an integer? Are these equal? Okay, it's grade 11 math class, everyone. I'm getting a little worried. Are those two equal? Holy crap. I'm going to add this one. Are those 3 equal? Yes. Okay, good. Whew. All right, I'm getting a little nervous. So, fractions, there's also something else there. Are decimals rational numbers? Are fractions related to decimals? Yes or no? Yeah. How do you get a decimal if you have a fraction? You divide, right? So, 2 over 5 is 2 divided by 5, yes? And if you do that with your calculator, you get 0.4, yeah? So, does that mean this is equal to that? Gentlemen, thank you. No. There you go. Are those equal? So is that a rational number? Because if something equals something, and they both equal something else, they both equal each other, right? Okay. Is this a rational number? It's a yes or no question. I know, I'm going to ask partie. You have no idea what I'm talking about because you're not paying attention. That's okay. But now you are. Is that a rational number? Why? It is a bunch of integers, but it's a decimal. So that makes it a rational number. Okay? Make it a fraction. Yes, yes, yes. Over 10,000. Absolutely correct. Well done. Yes, obviously. Yes. Well done. Now, what if I did that? Is that a rational number? What does that bar mean? It keeps continuing. 1735, 1735, 1735. Is it a rational number? Why do you think not? Because it doesn't end. Okay. What's 1 divided by 3? Does that 3 ever end? Is 1/3 a rational number? Yes. So if it repeats, is it a rational number? Yes. So is this a rational number? Okay. What about this? 1735 ... This is the tricky one. This one you actually have to think about. Does the 1735, does that value continue? Navi. Okay, it's the second time I've called on the back 4. There's a reason. Will the back 4 be split up very soon unless things change? This is where you say yes or no. Yes. Yes, they will be split up very soon. How soon is very soon? The end of this sentence, unless things change. Got it? Okay. Now I'll ask again. Does that mean 1735 continues? Yes, it does. What is the next number? Do you know? No, you do not. So right now, can you say with certainty that that is a rational number? No. Is everybody good? What if I gave you this? 0.714395524. Rational? Why? Because it ends at the 4. Is everybody good? Excellent. And then we get to irrational numbers, which is the next thing that screws everybody up. What's the most famous irrational number? Pi. Because pi is just the circumference divided by the diameter. But neither one of those would be integers. There's a lot of other famous irrational numbers. For our purposes in high school, we're going to use pi, and that's it. There's a bunch of others. Don't worry about it. But there's also all of these. Square root, no, I lie, any root of x. That doesn't work. If you put this on your calculator and it fills up the whole screen, it's going to be irrational. Everybody cool? So for example, square root of 4 is what? 2. 2 is rational, so that means the square root of 4 is rational. If you do the square root of 5 on your calculator, what do you get? Whole screen fills up, so that is irrational. And you all know that already. Now, up until grade 10, so last year, whenever you were faced with something like this, you would punch into your calculator and round it off, wouldn't you? But in grade 10, you were taught, hopefully by your 10th grade teacher, that we want you to leave it like that. So for example, if I had the square root of 48, which is irrational, you would break it down to something that looks like this, which of course is 4 root 3. I'm going to remind you how to do that in case you forget. You don't need to worry about it. But in math class, that's what we're shooting for. We don't want the decimals. Are we all clear? Excellent. Now it is 12:42, and this class was fast, quick like bunnies. And this class goes until 1 o'clock. So here is what you have to do for me today. Oh, one other thing I forgot. Why do I have to have that word in the title? Why can't I just call it the number system? Does anybody know? Oh, I'm so happy I get to tell you something you actually don't know today. Nobody knows? Pardon me? They are real numbers, yes. They exist. We can explain all of these things. So, what's the opposite of real? Fake. Anybody think of another word? Not real. I'm 5 years old and I have a little lion that follows me around everywhere. Who is that? My imaginary friend. Yes. For all of you that are considering future math and the numbers are problematic for you already, there's already an infinite amount of them. There is also imaginary numbers. Like math wasn't hard enough with the real ones. There are imaginary numbers, which are things like this, the square root of -9. Doesn't exist, does it? Because 3 times 3 is +9, -3 times -3 is +9. There is no square root there, is there? But math people had to invent imaginary numbers to explain how the universe works. Don't worry about it. It won't come into play for you until second year university. But up until then, get to really know the real number system. Because when these come along, then it makes you barf your Cheerios from the morning. Okay? But you don't have to worry about them. I just wanted to say that's why we call it the real number system. Because there's another whole system of fake numbers. Okay? Okay, here is your job, and you have 15 minutes to do it. You're not going to have any math homework. And 2 things. One, I apologize. I talked longer than I normally do. I don't like to only give you 15 minutes. I like to give you enough time to get what I want you to get done in class so you don't have homework to do. That being said, remember, you're not going to succeed in this class unless you practice. So if you blow off the time I give you in class to talk with your friends, then you'd better make sure you do that stuff that night. Everybody with me? Because the class does not stop for you. I have to get through a whole bunch of stuff to get you ready to take next year's class if you're going to take it. Cool? Okay. I want you to fill in page 6 to the best of your ability. It will not take very long. You will walk out of here with no homework, except to go on to Google Classroom and tell me the problem questions. Are we all good? Excellent. Oh, and what was the answer to the dad joke? Did anybody even check it? Did I give you a dad joke? Oh, I thought I did. Never mind then.